Hey, what's up, y'all? Thanks so much for joining me on another processing tutorial. In this video, we are going to continue looking at how to create the illusion of motion by keeping our camera still and moving things along the z-axis. And today we'll take a look at how we can create this endless tunnel effect that you see going behind me here. What we're going to do is use a little bit of math to calculate a bunch of positions along a Bezier curve and then draw a bunch of shapes at each of those positions. Taking this approach is going to allow us to do some pretty fun things. We'll be able to curve our tunnel around the Bezier that we've defined like this. We'll also be able to add some rotation, get kind of like a twisted tunnel effect, which is really nice. And then before the video ends, we'll also take a look at the perspective function in processing, which will allow us to change the field of view so we can make it look like the tunnel is super, super long like this, like the back of the tunnel is really far away from us, or we can also make the tunnel look like it's really, really short and we're really close to getting to the end of the tunnel here. So let's dive in and visit Wikipedia really quick to take a look at the math that we're going to need to actually program our sketch. So I would definitely recommend coming and reading about the Bezier curve. Very interesting information, some history here. But for the video, all we really need to do is come down here to the section on cubic Bezier curves, because that's the kind that processing implements, right? It's got these 4 points, a starting point, an ending point, and 2 control points in the middle. And then we'll just come down here and take a look at the explicit form of the curve, right? So b of t, this will give us either the x or the y position, or the z position when we start to work in 3D. Is equal to 1 minus t cubed times p0 plus 3 times 1 minus t squared times p1 plus 3 times 1 minus t squared times p2 plus t cubed times p3 as long as t is in between 0 and 1. So this is going to work a little bit like the lerp function. I think we did some p-vector lerping in a previous video, right? So we have that value, this case it's going to be t, right? That goes between 0 and 1, and if it's 0, it'll get you the point right at the very beginning, that starting point. If it's 1, it'll grab you the point at the very end, and then any value in between 0 and 1, it'll calculate the space in between. So I've also created a little screenshot for us so we can leave that up on the screen so that we don't have to kind of switch back and forth between the Wikipedia page and our sketch window here. Okay, so let's get started. We'll just make a void setup, void draw, and let's do our usual size, 640 by 480. And how about the background for now? Let's turn it white. Okay, cool. So now if we look at this formula here, we're going to need a few things. We're obviously going to need the 4 points for our Bezier curve. We're going to need a variable to contain our t value, and then we'll have to maybe give ourselves another p-vector to actually kind of store all of the results in. So let's go ahead and do that. Let's say p-vector p0, p1, p2, p3, and b of t. And then we'll say float t. Okay, so I think first thing I want to do is just kind of draw the Bezier curve itself. So let's define all of these p-vectors. We'll say p0 equals new p-vector. Let's make this one at the bottom in the middle of our screen. So we'll say width divided by 2, height. And then we'll make the ending point, let's put it in the top right corner. So we'll say new p-vector at width and 0. And then let's put our control points in the middle of the screen, and we'll just stack them on top of each other for now. Just have basically one control point. So I'll say p1 equals new p-vector width divided by 2, height divided by 2. And then since I'm just going to make them the same, I'll say p2 equals p1. Great. Okay, and let me just also initialize bt like so. And then let's go ahead and start plugging in. Oh, and you know what? Actually, let's go ahead and make this t value. Let's say half. So we want to calculate the point in the middle of this Bezier curve. So let's come in here and we'll say Bezier p0.x, p0.y, p1.x, p1.y, and then p2.x, p2.y, p3.x, p3.y. Okay, and I think if we've done everything correctly, we should have our Bezier curve here. Okay, so now what we're going to do is go ahead and put this formula into our sketch so that we can calculate points along this Bezier curve. Let's work on finding the x-coordinate of our point along this curve. So let's say bt.x equals, let's see, 1 minus t cubed. So I'm going to say power 1 minus t to the third power, right, cubed, times p0.x, right? And that's going to be our first little bit. So I'm going to put this in parentheses like so. And I'm going to add the next bit, which is 3 times 1 minus t squared. So I need to say power 1 minus t squared, like this, times t times p1 dot x, since we're calculating the x. Let's put all of this into some parentheses to keep that together. And then we'll need to do p2, so we'll say 3 times 1 minus t times t squared, so I'll say times power t to the second power times p2 dot x in our case, right? And then the last little bit here is t cubed times p3. So I'll say plus power t raised to the third times p3 dot x. And I'll go ahead and put this in parentheses as well, and then punctuate that with a semicolon. All right. So that should get us x, and for us to find y, all we need to do is copy and paste, and then just grab the y values for all of our points, like so. I think that should be everything we need. Okay, and then all we have to do, let's draw an ellipse. So let's say ellipse at bt.x, bt.y, and let's make this 10 pixels by 10 pixels. And I think I'd also like to make it red just so that we can see a little better. So let's say no stroke, and then we'll say fill 255, 0, and then so that my Bezier looks normal, I need to say stroke 0 and no fill. Okay, let's run the sketch and see what we get. Okay, cool. So we've got our Bezier curve, and we've got our red dot here right in the middle of it, because t is equal to 0.5. So let's double check our math and make sure that this is going to work for all values of t. Let's come up here and let's say t equals map mouse x between 0 and width between 0 and 1. Run the sketch again. Okay, that looks promising. Nice. Great, and as you can see, moving my mouse left to right across my display window here moves this point along our Bezier curve. So now we've got this math, we know the formula is plugged in correctly, and we're able to calculate any point along this line by changing the value of t. So what we want to do next is actually calculate a bunch of different points, right? We don't just want one t, we want multiple t's, right? So let's start, we can turn this off, and instead of making just a single floating point variable for our t, let's go ahead and make it an array, and we'll say equals new float array. Let's put 10. Let's put 10 points in here, right? So in order to populate this array, let's go in here into our setup loop, and we'll say for int I equals 0, I is less than 10, because that's how many things are in this array, or sorry, that's the size of this array, and then I plus plus. Okay, and then every time we run through, let's say t of I is equal to a mapping of I which goes between 0 and 9, and we want that to go between 0 and 1. Okay, and then as you can see, this kind of messed up our math. That's okay. We are going to, first of all, have to put this inside of a for loop. So let's say for int I equals 0, I is less than, what was it, 10, I plus plus. Oops, forgot my parenthesis. Good. Let's take all this stuff, stick it in here, and now we can come and say t of I, and that will grab every single t value in this array that we populated in setup. Okay, and I think that's going to take care of it all for us. Let's format that. And then we're also going to want to take the code that actually draws the shape for us, put it in here, or the ellipse, the little points, right? Okay, that looks pretty good. I think this is going to give us what we want. Let's run the sketch again, see what happens. Okay, so as you can see, right now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points all spread out along this Bezier curve. Nice. All right, so now let's see if we can start thinking about how we're going to actually set up our endless tunnel sketch. So now we know how to calculate points along the Bezier curve. We know how to create an array of t values and spread them out along the curve, and then draw a bunch of shapes at each of those points. So first thing we need to do is actually put this in 3D. So let's say P3D, and we'll also need to kind of alter our points for this Bezier curve to exist in 3D. Before we do that, let's think a little bit about, this third dimension, so our z-axis, right? So we're going to have a value that's going to be, our z maximum, like the closest it can get to our faces, right, at the front of the display window. We're going to have a value that's our z minimum, right, at the very back of the window. And then we are going to need to figure out, how many shapes do we want in between those 2 points, right? The beginning and the end of our line. So what we can do is we can add those two values together, right? We can add the minimum and the maximum, and then we can say, okay, I want there to be some distance between each of these, and then we can divide it, the sum of the total distance, we can divide that by the distance we want to be between each shape, and that will give us the number of shapes that we'll need, the number of t values, right, that we'll need to kind of fill up this line. So let's say z max equals, let's say 20, right? And let's say z min equals negative 1200. And then the distance between each of our shapes, let's say z distance is equal to 45, right? Then what we can do is we can say int num shapes, right? Because this is the number of shapes that we want, right? Is going to be equal to z max, and we can use a minus here because we've got a negative value and we just want the total distance here, right? So we can say z max minus z min divided by z distance, right? And then we'll need to cast this as an int, or I'll need to use the int function. Okay, and then I can come in here and I can say num shapes, right? So now I'm going to use a max and minimum z value. I'm going to define a space between each of the shapes, and then I can use this formula here to calculate the actual number of t-values, or the number of shapes, right, that I'm going to need in this array of t-values. Cool. And so instead of drawing my line here from the bottom to the top, I'm going to, take it, I'm going to lay it down. If you can kind of think about rotating it around the x-axis as it looks here. I'm going to do like this with it, right? And what I'm going to do is start at 0, 0. And we're going to put the z value for the starting point at the maximum, right? So this is the first point is here at the front of the display window, right? And then the last point is also going to be at x and y are 0 and 0, right? But I'm going to put the z value at z minimum here, right? And then the control point I'd like to put actually right in between the two. So I can come here and I can grab this. I'm going to keep these also at 0, 0. I can put this formula in here, and instead of dividing by z distance, I'll just divide by 2. So this will give me the total distance between the starting and the ending point, and then I can just divide that by 2, and that'll put my control point right in the middle, right? Okay, so now I've got my Bezier curve set up in 3D. I'm not going to need this code anymore, so I'll get rid of that. Get rid of that for now as well. And what I'm going to need to do, oh, and I also actually, before I go into my draw loop, I'm going to need to also change how we're populating our array of t-values here. So I'm going to say if I is less than num shapes, right, which I know it goes between 0 and num shapes minus 1, right? And so that should give me all of the t-values that we're going to need to initialize our sketch. Okay, and so now I can come into my draw loop. I'm going to need another calculation here for my z coordinate. So I'm going to just change all of my points here on this line to z. Great. So now I should be able to calculate the x, y, and z coordinate along the Bezier curve that we've defined with these points here. And what I'll do is I'll need to translate. So I'm going to center this line because I drew it starting at the origin, 0, 0, just to kind of keep the points simple up here. So I'll say translate to the middle of the screen, width divided by 2, height divided by 2. And now I'm also going to need to update this. I'll say for num shapes, there we go. And what we can do, okay, so we've calculated the positions. We've got our stroke and fill, and so we're drawing these dots. I don't want to draw dots. I'm actually going to draw rectangles, right? So let's change that. We'll say rect at the origin, and we'll say width and height, right? So that way the one that's at the very front will be the same size as the display window. It'll look like, we're kind of inside of that tunnel if we make it width wide and height tall. And I don't want to have no stroke. And I do actually want no fill. So I can say no fill. And then I'll say stroke. I think I had a green one in the example, so we'll stick with that color. And I know I'm also going to want to draw all of my rectangles from the center. So I can just come up here into setup and say rect mode center. I know that's not going to change for this sketch. Okay, so that's got that. I'm also going to need to say push matrix, pop matrix, since I'm going to be drawing a bunch of them. And let's translate now to bt.x, bt.y, and bt.z, and then draw our shapes at these coordinates, right, that we've calculated along our Bezier curve. Okay, I think this should be enough code to get us started. Let's see what we get. Sweet. Okay, so we've kind of got our endless tunnel. Oh, I forgot. We need to make our background black. Okay, sweet. So we've got our static tunnel here now. Let's go ahead and take a look at how we are going to sort of start to animate this, right? So what we want to do is for every t value in our array, we're actually going to want to increment it, right? So we'll say if t of I is less than 1, right? Let me make a speed variable for us as well, say float speed. Let's set this equal to 0.001 to begin with. I think it actually is going to need to be negative like this. Right, actually, we're going to want to be subtracting from t, right, so that the squares come toward us, right, because we put the starting point at 0, right, that's the front, right, so we want these actually, I'm not going to say if it's less than 1, I'm going to say if it's greater than 0, right? So if it's greater than 0, go ahead and t of I equals, let's constrain t of I plus equals speed between 0 and 1. Okay, so that should get us set. And what's going to happen is this will start to move each of the shapes toward us. Then I'm also going to want to make sure that if it's at 0, right, so once it gets back to 0, then we're going to reset it. So we're going to send it back to the end of the line. We'll just say t of I is equal to 1. Okay, and I think this will be enough code to get us animating the tunnel. Nice, this looks good. Okay, so now we've got our endless tunnel, and it just keeps going and going, and the loop looks pretty good. So let's take a look now at how we might make some of the visual enhancements that you saw in the example code. So what I'm going to do is I'm going to first create the fade out effect that you all saw in the example. So what we can do, right, is we're going to map our z value. And so our stroke here, right, instead of it being 255, what we're going to say is if bt.z is less than 0, for example, right? So if it's further back than 0, the z position, what we want to do is map our stroke here, right, to the z position. So we'll say bt.z, which we know goes between z min and z max, right? And we want to map that at the minimum value, we want it to be dark, and at the maximum value, we want it to be bright. Okay, so that should take care of that. Otherwise, if it's past 0, right, so if it's like sort of more in the foreground, we can go ahead and keep it lit up. But this will kind of create that effect where it looks like the end of the tunnel is sort of disappearing into the shadows. Let's run the sketch and see what that looks like. Nice. Okay, and so you can see, right, this kind of makes it look like the end of the tunnel is a lot further back. Looks really great. Awesome. Now, the next thing I want to do is kind of play around with the stroke weight. So what I'm going to do is say stroke weight, let's make that 5, right? So this will make the lines look a little bit thicker in the hallway, which is going to make things look a little better. And then I'm also going to play around with the scale, right? So things, you know, that are closer to me, I want to look bigger, and things that are further away, I want to look smaller. And so I'm going to actually alter the scale, and we can actually just use t for this. We don't need to use the z position. So we can say, after translate, right, we can say scale, and let's map t, right, which I know goes between 0 and 1. And so when it's at the front of the screen, I would like for my scale to be 1. And when it's at the back of the screen, let's say like 0.1. Let's see what that looks like. Okay, sweet. So that's kind of creating that scaled effect a little bit better for us. It's looking good. Okay, let's, what else do we want to do here? Let's play around with the rotation. So let's see, I'll say float rot. And let's initialize that as 0. So I'll say rot equals 0. And then what we're going to want to do is we are going to, after our translate, we'll say rotate z, right, by rotate, the amount of rotation that we've defined here. And what we'll want to do is up here, we can say rot equals map mouse x, which goes from 0 to width. Let's make that go between -2 pi and 2 pi. So we're going to change that rotation, right? And actually what we want to do is, okay, if I do it this way, right, the entire tunnel will get rotated around, right, as one giant kind of unit, right? Well, if we want to get that twisted tunnel effect like we did before, what we're actually going to do is scale, or excuse me, we're going to map the amount of rotation based on the t of the t value. So I can say map t of I, which I know goes between 0 and 1, between 0 and the amount of rotation. Okay, cool. So I think this should work and give us this rotation that we're looking for. Okay, cool. So it looks like we've got our rotation code working here, which is excellent. So now we can make this sort of twisted tunnel effect. All right, cool. Let's play around with how we might actually move the end of the tunnel around. So let's come in here. And then what we can do, right, is all we have to do is just come and play around with the x and the y position of our endpoint. So I can say p3.x equals map mouse x, which goes between 0 and width, between 0, well actually let's make it between negative width and width. And then let's say p3.y equals map mouse x between mouse y between 0 and height, and we'll map this to negative height to height. Let's try this. Put that control point in a different spot. Oh, okay. So that's working a little bit better. This is actually, there we go. So now we can bend our hallway. Different directions like this. Nice, okay. So we've got the ability to kind of change the scale mapping based on our t value. We are changing the brightness of each of our shapes, again, based on that t value. We are able to curve our hallway, our tunnel, our endless tunnel here. You know, we've got a speed variable up here that we could change. And we're also able to play around with the rotation depending on whether or not we have that in our code or not. So last thing to do in the video here, let's take a look at our perspective function. So we're going to go to the processing reference and take a look at this function here, right? Definitely recommend reading all of this text on your own time. What we need to do is basically just grab this code here from the example and copy it into our sketch. Oops. And what I'll do is say float FOV, camera Z, and then we'll just get rid of that, and we'll get rid of that, and then this we're going to come and put into our draw function, like so. Let's put this on the same line. And then actually this is a little bit different than what's written here. So camera Z is actually height divided by 2 divided by this little thing here. Okay, so this should give us the default perspective. And this also, okay, so this value, this is something else I want to show you guys. The Z far, right? So we can also play around with this. This will allow us to see further into the back of the window before we start clipping things and, you know, stop showing things. So what we're going to do, minimize this, and we are going to just increase this to, let's say, like 3000, so that we can see a little bit further in. And then, so the field of view, the default was pi divided by 3, 1/3 pi. So what we can do is we'll quit messing around for now with the bending of the hallway, and we'll come in here and we'll say FOV equals map mouse x, which goes between 0 and width between, let's say, 0 and 2 pi, just to see what that gets us. Okay, so now when we run the sketch, we should be able to see a little bit further into our sketch window. And when we move the mouse back and forth, we should be able to make the hallway look a little bit longer or a little bit shorter, depending on our field of view. Okay, here we go. So now we're right at the back of the tunnel. And you can see as we start to increase our field of view, that kind of messes up this illusion here. So we might need to actually make Z max a little bit greater if we want a field of view. So I can come back up here and I can say, instead of 20, let's make this like 100 and see what we get. All right, so we're still kind of having a bunch of stacking up at the beginning. Okay, there we go. So as long as we make the maximum Z far enough away, we can still use, you can see if I wanted to have a really crazy field of view, I would need to increase that even further. But for something like this, still getting a pretty decent result here. All right, nice. So this brings us to the end of the video. We've covered basically everything I wanted to here. I'm going to encourage y'all to get creative with this. You know, maybe play around with animating some of the different effects, the modulations that we made to this. Use your own custom shape. You could, you know, import an SVG. You could define your own custom shape inside of a P shape. You know, kind of get creative with the colors that you're mapping. Maybe it's, you know, different colors in different parts of the hallway. But yeah, go ahead and experiment with it. Can't wait to see what y'all come up with, and I'll see you in the next video.